The area of a triangle is 1/2 base times height. If the triangle is not an equilateral triangle, then the height is not usually given, but we can go ahead and find the height using trig functions. Now we'll derive the height. Suppose we're given the following triangle. We'll call the bottom piece of this triangle the base, and we'll call this side C. If we know the angle between B and C, then we can always find the height. To do so, we'll go ahead and form a right triangle. Then we know that sine theta is going to be equal to h divided by c, which means that the height is going to be equal to c times sine theta. Replacing this in our area equation for a triangle, we get that this is going to be 1/2 the base times c times sine theta. If the angle given theta is not an acute angle, we can derive the same equation as follows. Here's our angle theta. Again, we'll call the bottom edge B, and we'll call the adjacent edge C. We can form a right triangle, like so. And here we're going to get the reference angle theta bar, which is going to be pi minus theta. And if we label this edge of our red triangle as, again, the height of our blue triangle, then sine of theta bar is going to be equivalent to h divided by c. So the height is going to be equal to c of sine theta bar. Rewriting our area equation, again, we'll get the area is 1/2 of the base, this time again c times sine theta bar. And the key step here is that sine theta bar is equal to sine of pi minus theta, which is equal to sine of theta. So this step here we haven't shown, but we'll see why in the next section when we explore why sine theta and cosine theta are even and odd functions. With this last identity here, we can upgrade again our area equation to be 1/2 the base times c of sine theta. We'll summarize this result now. The area of a triangle with base c, one side length b, and angle theta, where theta is either an acute angle or a non-acute angle, is given by the following formula. Area is 1/2 the base times c sine theta. Let's find the area of an equilateral triangle. Let's sketch the information that we're given. We have an equilateral triangle, which means each angle is 60 degrees here. And we're also given that each side has length 10. Writing out the formula, this is area is equal to 1/2 the base times our side length c of sine theta. If we let 10 be equal to the base and c is equal to 10, then recall c of sine theta is the height of our equilateral triangle. So now we can just plug in all the values that we have. This is equal to 1/2 of 10 times sine of 60 degrees. And I left out the base 10, so there should also be a 10 here. Simplifying the numbers that we do know real fast, we'll get 50 times sine of 60 degrees. We can evaluate sine of 60 by looking at a 30, 60, 90 triangle. And recall that trig functions are again ratios, so it doesn't matter what the length of the sides are for this 30, 60, 90 right triangle. but the things that we do know is the side opposite to 60 degrees is the square root of 3 divided by 2. The adjacent side is 1/2, and the hypotenuse is 1. Therefore, sine evaluated at 60 degrees is the square root of 3 divided by 2, which means 50 times square root of 3 divided by 2 is our solution. And if we plug this into a calculator, this is approximately 43.301. This is the area of our equilateral triangle.